Namaste students, Kushal Vidya. I, JVM Dr. Biotechnology, Assistant Professor Vidyapeeth, Women's University, Jaipur. In today's session, we are going to discuss about the determination of the hardness of the water. So, what is hardness? So, generally, the hardness of a water is defined as the definition as the measure of capacity of a water to precipitate soap. That is the capacity of water to form lather with soap. So here the hardness content dissolve is due to the dissolve of minerals such as calcium, magnesium, iron, sulfate, etc. So the degree of hardness is measured as the part per million ppm or gram per gallon GPG. Okay? Part per million ppm and gram per gallon, that is GPG. So, if the water with different degree of hardness is used for different purpose, such as the household and industrial purpose. So, the soft water which have GPG less than 1 and part per million less than 17.1 mg per liter, then it is a soft rating. Slightly hard is 1 to 3 in GPG and 17 to 60 in part per million mg per liter. So hard water is normally 7 to 10 in GPG and above 10 it is very hard water. Whereas in the part per million, if you can see it is 120 to 180 and above for hard rating. So why to determine the hardness? What is the requirement? It is essential to know the hardness of a water since it is defined for the purpose of it. Hardness is not a health hazard, but it cannot be used in industrial applications such as boiler, pipes, etc. So if it has a tendency to form a calcium carbonate precipitate, which later resulting in the sludge or scale formation. So the determination of the hardness of the water can be determined by the methods such as the gravimetric analysis, that is EDTA, titration or atomic absorption, etc. In the above methods, the EDTA titration is the most inexpensive and simple way of determining the hardness. There are two types of hardness, temporary and permanent. Temporary hardness is due to the bicarbonate ions, calcium, magnesium bicarbonate, or being present in the water. It can be removed by the heating the water. For example, calcium uh, bicarbonate when react break down to form calcium carbonate plus calcium carbon dioxide plus water. So the permanent hardness is due to the chloride and the sulfide present or in the calcium in the form of calcium or a magnesium or a iron or a sulfide ions. It cannot be removed by boiling. The permanent hardness is usually determined by titrating it with the standard solution of ethylene diamine tetraacetic acid EDTA. EDTA is a complexing or a chelating agent used in the capture the metal ion. This causes the water to become softer, but the metal are not removed from the water. This method includes a series of titration to determine the total permanent, temporary, or a calcium magnesium hardness of the given water sample. First, the EDTA solution is standardized by titration. It is against the standard calcium chloride. It is normally found out that the end product as it appears is a steel blue color Then the total hardness is found out by titrating the water sample by adding the buffer solution of EBD indicator against the standard EBD solutions with an endpoint as the same scale below. So the hardness n into 50 into 1000, that is n is the normal. The permanent hardness is find out by titrating the boiled and the filtered hard sample against the EBD. So the temporary hardness is found by the subtracting the permanent hardness from the total hardness. The calcium hardness is found by the titrating the water sample against EBDA solution, where the endpoint appear to be the purple color, and if necessary for the magnesium hardness is found by the subtracting the calcium hardness from the total hardness. Mechanism. EDTA is a versatile chelating agent. A chelating agent is a substance whose molecules cannot be with several bonds to a single metal ion. So chelating agents are multiple dentate ligands. A ligand is with so at the end of the titration, D is released free as a result in the formation of a blue color. EDTA complex are the metal ions, while EBT is secondary free. Carbon are black, hydrogen are white, oxygen are red, and nitrogen gives flow. So calcium ions give looks like a green ball. So when if you are doing the complex structure, the necessary conditions to be maintained while doing the titration to keep the pH at about 10. The advantages and disadvantages. Advantages, it is very simple and fairly accurate, and it is cost efficient, and only a burette and a conical flask are required. So it is also quick time efficient process when compared to gravimetric analysis. Disadvantage is that it might be some human error due to the solution may be handled by the human, or EDTA grab all the metal ions in the water, not just calcium ions. So we cannot know the true concentration of calcium or the other cause of an experimental error, that is 1% fine, but that is acceptable. Thank you. This session is powered by 2.0 Jyoti Vidyapeeth Women's University, Jaipur. If you have any queries, we'll discuss in the problem solving session.